Okay, so we're going to take a look at problem number 1112. So in this case, we have a belt drive. It's desired to couple with a motor that is going to be processing corn syrup. So it has a 25 horsepower electric motor that's rated at 950 RPM. So that's going to be our input. And the mixer, our output, has to operate close to 250 RPMs. Okay. Select an appropriate belt size, commercially available shivs, and a belt for this application. Also, calculate the belt speed. That's going to be the V, and the center distance. So I am going to reference. So first of all, this particular problem is very similar to one that we did in our practice problems, and that is going to be problem 11-2. So we're going to use the process that they have here. Obviously, the numbers are going to be a little bit different, but process-wise, it's very similar. So that way you at least know that something that we've already worked on that you have can be helpful as well. So here they want us know step number one is to determine the appropriate belt size. So the belt size is going to be that 3V, 5V, or 8V. Now, what we need to do is we're going to use on page 304, the chart that we see up here. This is industrial V-belt selection chart. And this is where we are going to use the design horsepower, which if I remember correctly, it was 25 horsepower. Yes. So 25 horsepower. So that means here's 10, here's 20. So the number in between is 25. And then our faster shiv or faster shaft RPM is 950. So I'm going to just scooch up to the line for 1,000. And I'm going to go over to, let's see, 20, let me see, 20, 30, 40, 50. So 25 is right about in the middle here. And we're going to go up to about 1,000. And it looks like it's just, inside of the 5V section. Okay. Now, I want to emphasize for everybody that when I select something on this chart, that is a place to start. Okay. Sometimes we may need to go to a different belt size. Okay. Now, if you recall, 3V would be like the smallest. 5V is going to be the medium, and then 8V is going to be the largest that we're going to be picking from. There are other sizes as well, but for our purposes in the book here, we're going to stick with these three. Now, if you need to change belt sizes, you never go down. You will always go up. So if we find that we don't have shivs that are going to be appropriate as we try to select in 5V, then we would go up to the next size. You don't go down. You don't want to undersize your design because remember belt size is based on, again, that horsepower. So as the horsepower goes up, which is the biggest driver, if you would, for the size of the belt, that goes up. And again, if we're at 25, we're already kind of on the edge, if you would. We want to then go into the next area. So just know that as an option when you're choosing your belts. Now, we're going to notice here, so we'll use this example again. So we picked the appropriate belt size. So for this problem, okay, so this is problem 11-12. Number one, our belt size is going to equal 5V for right now. Okay, that's where we're starting. Okay. And then the next thing they want us to do is they want us to determine the ideal diameter for the driver shiv. Okay. And what they're going to do is, and I'm going to scooch up over here. They're going, and this is on the next page, they're going to use the diameter here, and they're taking that belt speed equation and rearranging it. So let's see how they got this right here, because this is not a standard equation. The belt speed equation is at the top of page 306. Okay. And I'm going to kind of put this here, step number 2. we're going to start with our belt speed equation is going to be equal to, now normally it would be the radius, but because we can calculate we want to calculate a diameter, we're going to say diameter 1 divided by 2. So that's really the radius of the diameter, okay? Times the rotational speed of the input. Okay, so this is the diameter of the sheave of the input, and this is going to be the rotational speed of the input. Now, for the problem, we know that W1, okay, is equal to 950 RPMs. That's off of the motor, okay? We're not given the belt speed, okay? But as a guideline, belts efficiently run, or most efficiently, are going to be anywhere between 4,000 and 5,000 feet per minute. So in this case, in this example, they just picked the middle number here, 4,500 feet per minute, okay? So that's what we're going to use kind of as our guide. We're going to say, okay, that's 4,500 feet per minute, okay? So in this problem then, the only unknown is going to be our D1. So what they did in that step, okay, on page 307, right here, they just rearranged that equation we're looking at right now, and they solved for the pitch diameter. So that's what I'm going to do. I'm just going to rearrange this equation. So I want D to remain by itself. So I'm going to multiply up times 2. I'm going to divide by W1. So D1 is going to be equal to 2 times the belt speed divided by W1. Okay. Now, as we look here, we are going to want our diameter in inches. Okay. We're going to want that in inches because, and I'm just kind of thinking ahead. I kind of know this, but you want to think about this too. We are going to be picking commercially available ships, and all of these pitch diameters are in inches. So the numbers that are down here in our 5B column, they are all in inches. So as we look at this diameter then, you'll notice that our belt speed is in feet per minute, and this is in RPMs, okay? So we need to get them into the appropriate units. So first of all, we know that W1 in this equation always has to be in radians per. Now, since both of these are minutes, I'm going to leave them both in minutes. I'm not going to go to radians per second because that way the minutes are going to cancel, and it's just one less step in my unit conversion. So for W1, I'm going to take 950 revolutions per minute, and I am just going to convert that to, sorry, zoom out here a little bit. I'm going to say 1 revolution is 2 pi radians, right? Kind of on top of my book here. Revolutions cancel, and my W1 is then going to be in radians per minute, okay? So 950 times 2 times pi, looks like it's going to be 5,968.9 radians per minute. Because radians are on top and minutes are still left, okay? So this is going to be the number then that I'm going to put in down here, okay? That's going to go in there. And then my belt speed. My belt speed is 4,500 feet per minute. But like we said, we want our diameter to be in inches. So we need to convert this to inches per minute. So our BB of 4,500 feet per minute, we just want to convert that into inches per minute. Okay, inches per minute. So that means 1 foot is 12 inches. And then my BB, 4,500, 12 times, it's going to be 54,000 inches per minute. Okay. And that'll be the number then that we put up there. So now I can fill in my values. I can say, okay, D1 is going to be equal to 2 times 5968.9 radian. Oh, sorry, I have the wrong one on top. It's my V, not my W. My W goes on the bottom. I was putting the wrong one on top. So it's the 54,000 inches per minute. Okay, divided by, this is where I'm going to put my W, 5968.9 radians per minute. The minutes cancel top to bottom. Make sure you're putting your units in here. I don't want to see things magically appear. Okay. So now I have inches divided by radians. So radians magically disappear. Those magically disappear. So it's just going to be inches left over. So it confirms that I have the right units for the quantity that I'm seeking, which is the diameter here. Okay. So you can do your math. 2 times 54,000 divided by 5968.9. It looks like my diameter, 1, is 18.09 inches. Okay. Now, this is the ideal diameter for my input shift. Okay, my D1. So now what I need to do is I'm going to look on my list of commercially available ships. So back to table 11.1. In this column right here, you're going to notice that I have an 18, it says 18.5 here. Okay. So I'm going to say, all right. So my D1, 34. My D1 is going to be equal to 18.5 inches. Okay. And that's from table 11.1. Okay. I can't use the 18.09 because that's not commercially available. And the problem said we needed something commercially available. And that makes sense, right? So now, if this is going to be what I use for my small one, I got to find out what I'm going to use on my large one to get it to the 250 RPMs. Okay, so let's go back to our example. Okay, and see where we're at. So we did this step right here. We're right here. Okay, we're right here. So now we want to figure out what is my D2. Okay, my D2. So I'm going to take D2 and I'm going to multiply it by the velocity ratio. Okay, times D1. So D1 I already know, and I'm going to multiply it by the velocity ratio. Now the velocity ratio is going to be W1 divided by W2. Okay, so this is going to be my step number 3. My velocity ratio is going to be W1 divided by W2. I know that my W1 is 950 RPMs and my W2 is 250 RPMs. So these cancel out and my velocity ratio is going to be 3.8. Okay. So that means that my D2 needs to be 3.8 times larger than my D1. Okay. So we're now going to use that velocity ratio. I'm going to say, okay, D2 is going to be equal to that velocity ratio times D1. So that's going to be 3.8 times 18.5 inches, right? So my D2 would need to be, if I'm using the 18.5, it needs to be 70.3 inches in diameter. Okay. Now I look, is there something that's close to 70.3 in the V5 category? Back over here, pages to table 11.1. And you're going to notice, no, no, there's not. This only goes up to 27.9. This was where I said earlier, that means that V5V is not going to be the belt that we need. We need to jump up to the next size. Okay. So we're going to be looking in here. Now, we were given, in our case, we were given 18.09, okay? So is there something nice and close to 18.09? We've got really two options. You can go down a little bit, okay? So 17.8 or 18.8. There's really not a big deal either way because remember, this diameter was based on specifying 4,500 feet per minute, which was in a range from 4,000 to 5,000. Okay. So if we go down a little bit, we're totally fine. Okay. So I wouldn't recalculate that at this time, but I would take the smaller one, the 17.8. So what I would say here then is I would say not available. Okay. So now that means that I am going to start over with 8 V's. So my step 4 is new belt size equals 8V. Okay. Now I already know that my D1, what do we calculate? 18.09. Okay. And that doesn't change based on the belt size. That just is a size based on how fast we want that to go. So for an 8V, as we said, I'm going to do the 17.8 inch. Okay. And that is from table 11.1 again. Okay. So this is going to be my D1. So now if I want to calculate my D2, okay, step number 5, my D2 is going to be equal to that velocity ratio, the 950 to 250, which we already calculated, times D1. Okay. So this is going to be our 3.8 times 17.8 inches, because that's the commercially available one. And then D2 is 67.64 inches. Okay, that's what it's calculated out using exactly that value. So now we're going to look. Is there something close? Well, it goes a little bit over. So unfortunately, we're a little bit big. Okay. So what we can do is we're going to have to recalculate. And this is called the design process because we have to work with what's commercially available. Okay. So we're going to do this one more time. So step number 6, not going to work. We can say not going to work. These are called design iterations. So what we can do, remember when we used our D1 is equal to 2 times V of the belt speed, divided by W1. This was an estimate. We put it at 4,500 RPMs, right? Well, what if we go down to 4,000, which is still within the range? It's at the bottom of the range, but we can say this is going to be 4,000 feet per minute. Okay. But we need to convert that to inches per minute. So we're going to multiply that by 12 inches, 1 foot, feet cancel. So that means I'm going to take 4,000 times 12, and that's going to be my VB is going to be 48,000. So that'll bring my diameter down a little bit, and that's going to be inches per minute. Okay. And our W1 we already have in radians per minute, so we'll grab that from the first page. So my D1 now is going to be equal to 2 times 48,000 inches per minute divided by my W1, which was 5968.9. Okay. And that was radians per minute. Okay. So minutes cancel. Okay. And now my new D1 going to be 16.08 inches. Okay. Now, I need to look on that chart again, 11.1, to see what is closest. Okay. So far you guys follow me. So this is really our third iteration this time. We first switched to a larger belt using the same belt speed, but we still weren't getting our D1 small enough. So then we had to reduce the belt speed, okay? And we just recalculated a new D1, so it's smaller. So let's go and let's see. You'll notice that we have a 16.8 and we have a 15.8. So I would say 16.8 because we already went to the slowest optimal belt speed. So I'm going to use the 16.8 inches. Okay, is going to be equal to my D1. This is the commercially available. And again, this is from table 11.1, third one. Now, we're going to say, all right, let's now figure out D2 is going to be equal to that velocity ratio times our new D1. Okay, so we know our velocity ratio is 3.8 times 16.8. So our D2 is 63.8 inches. Okay, calculated. So let's see. Oh my gosh, it's right on. So we can use that one. That is actually a commercially available. So we don't even have to. Already listed in table 11.1. Okay. So yes, it is not a straightforward slam dunk. Let's just go for it. So now that we have our diameters picked out, now we can finish up the problem. Okay. And this usually is the part that takes a little bit of time. Okay. Because we have to work with what's commercially available. All right. So now let's go back to the problem and make sure that we're doing the rest. So select the appropriate belt size. So we actually are an 8V, commercially available shibs. We just picked those two. And then now the belt for this application. Also calculate the actual belt speed and the center distance. Now, if you remember, okay, we go back and we look at the belts. The available belts are based on a continuous length. So remember, we are in 8V now, okay? These are the available belts. Now, we also have a constraint of center distance. So on page 304, our center distance needs to be within this range. The diameter 2, which was the second diameter that we just calculated, is going to be, it has to be greater than, the center distance has to be greater than that diameter, but it has to be less than 3 times adding the two shib diameters together, pitch diameters together. So we need to first find out what this range is, and then we're going to pick a number in that range to then be our center distance so that we can then determine what our belt length is. Okay, and once we know what our belt length is, then we can calculate the actual center distance. So we need to first estimate it. Then we're gonna calculate the belt length, pick a number that is on our chart that is actually going to work for us, and then we can do the actual center distance. So again, a couple steps here. So this is going to be our step number 8. And this is where our D2, C, and then 3 times D1 plus D2. Okay. So our D2 was 68.3 inches. Okay. So we know that 63.8 inches. And then our C has to be between, and then it has to be less than 3 times 16.8 plus, oops, inches. I'm going to put the symbol 63.8 inches. Okay. So those two numbers, I just have to multiply that out. So that means that we need to be between 63.8 inches with our center distance and 241.8 inches. This is our qualifier, okay? And this is where, unless the problem gives us a center distance that we have to abide by or be close to, now we get to just pick something in between. So you can pick, I don't know, I'm gonna say 100. I'm just gonna say 100, all right? So I'm gonna start with a C equals to 100. And this is going to be a trial center distance based on what we can be in between, okay? The optimal size. So now that I have this, now I can calculate the length of my belt, okay? So the length of my belt is going to be equal to, I'm going to use this equation right here. So I'm going to write that in place. Q times C plus I over 2 D2 plus D1 plus D2 minus D1, square that, divided by 4C. Okay, so this equation right here. Now we're going to put the values in that we have. We have our center distance, our trial center distance. And I should say, I'm going to mark this as trial center distance. This is what we're going to try. We're going to calculate a length based on that center. And then we're going to see what's closest as far as belt length on our chart for commercially available belts. Okay. All right, equal to. So now we're going to put in our values. So 100 inches plus pi divided by 2. Our D2 was 63.8 inches. See, plus 16.0.8, sorry. 16.8 inches plus, on top is going to be 63.8 inches minus 16.8 inches. Square that, divided by 4 times 100 inches. Okay. I kind of broke them into their sections. And go ahead and that's right. So just want to see, do you guys also get the same value for those who are following along? I got 331.5. Emily did. Okay. I know this was your question. I'm not sure who else is following along. Okay, perfect. So now we're going to look at table 11.2. Okay, table 11.2 is on page 305. These are the commercially available V belts. Okay. And this is the length so that they fit over each one of our pulleys. Okay. So we're going to go down to the V or the 8V belt lengths. And you're going to notice that 335 is the next one up. Okay. So that's going to be our commercially available belts. Okay. Shouldn't have put a box around that one. My 335 inches from table 11.2. This one's actually my length. This one is my what it would be with that center distance. That now, because now we have an actual belt length that changed. Okay. If we calculated this and this number was exactly on our chart, then our center distance would be 100. But remember, we picked a center distance, a trial center distance of 100, so that we could figure out, okay, what's a belt off of that chart. But now these two numbers are different. So now we want to calculate the actual center distance. So go back over to page 304. Here is our center distance equation. It uses these variables of B that we calculate using that length and the diameter. So we really actually have to calculate B first. And then using this value, we're going to input that into the actual center distance equation. So that is going to be our step number 9. And I kind of book out of the way here. So step number 9, I need to calculate B. B is equal to 4L minus 2 pi two plus 1. Okay. Now this L is that value right there. Okay. And it's for the belt that we just picked off of our chart. So that's going to be 4 times 335 inches minus 2 times pi times 63.8 inches plus 16.8 inches. So our B value So I didn't do it a second time, but just want to get confirmation. I got 833.59 for B. Okay, perfect. So then now our C value comes from that equation directly above using these B's in there. Just helps to, it's an intermittent calculation to help keep it, reasonable as we generate the equation. So this is going to be our actual center distance, and I'm going to put ACT on the end here because that's our actual center distance. It's going to be B plus square root of B squared minus 32 times D. Square that. Okay. And then we're going to divide that by 16. Okay. That means we're going to have 833.59 inches plus the square root of 833.59 inches squared minus 32 times 63.8 inches minus 16.8 inches. Square that underneath. And then put that all underneath the radical. And then once we have that top line done, we divide it all by 16. It's kind of long. You should get something. You always are going to get something close to whatever your trial center distance was. If you get something radically different, then you know that you didn't do this correctly, okay? Because remember, our length was based on that trial center distance of 100. So your actual should be pretty close. And in this case, it is. Okay. So 101.5 for that center distance. Now, let's go back. Let's make sure we have everything that it's looking for. Emily, did you get the same number for your actual center distance? Maybe you're still figuring it out. That's okay. I'll wait. I just want to go back over the problem and make sure that we're covering everything here. Still calculating. That's okay. Take your time. It's a big equation. Worse. Guys, I hope you don't get this cold. I'm coughing and coughing and coughing. Sorry. Yeah, and just don't forget to do your squares in each one of the places, because if those are forgotten, and then you have to do the square root of everything underneath here, just make sure you do all those operations, because it's easy then to forget one. Okay, got the same. Awesome, awesome, awesome. Okay, now let's go back underneath and make sure that we have everything for this problem, or finish it up. So we selected the appropriate belt size. We have commercially available shivs off of our chart. We ended up going up to a belt size of 8V. Then we calculated the center distance, but now we have to do the actual belt speed. Okay, we didn't do that because we estimated our pitch diameter based on the belt speed that we wanted, but we now need to figure out what is the actual belt speed, okay, based on our diameter. So we have to do that one last step. So 10 is going to be our belt speed. It's going to be equal to, now this comes from, excuse me, this comes from the equation at the top of page 306. And I'm going to use that diameter divided by 1, because we have our D1, I'm sorry, diameter divided by 2 for the radius. We have our D1 that we calculated, or that we determined. So we're going to take D1 over 2 times W1. Excuse me. And our D1 now, the actual shiv that we picked was 16.8 inches, not the 16.08 that we calculated as an estimate, divided by 2 times. Now, this is that W that has to be in radians per whatever, right? So we got it in radians per minute, okay? So 5968.9 radians per minute. We can't use RPMs here. 5968.9 radians per minute, okay? So this is going to get us in inches, right? Multiply that per minute, all right? So velocity of that belt then in inches per minute, I'm going to take 16.8 divided by 2, and then multiply it by that 5968.9. $50,138.8, and that's inches per minute. Okay. Now, as we know, when we report belt speed, it's normally going to be in feet per minute. So we're going to convert that so that there is 12 inches in 1 foot. So inches cancel in my belt speed. Should be 4,178 feet per minute, or you can do FPM, okay? Now, remember, our optimal range is between 4,000 and 5,000 feet per minute, okay? As a guide, all right? That's a guide that's in the chapter here. So we do fall within that range. So this is okay because it's between 4,000 and 5,000 feet per minute, okay? Which we were expecting because we based it on 4,000. If you recall, we decreased that speed to the lower end of that range so that we could get our diameter of our shiv as a reasonable number that would commercially be on that list. All right, so as we look then at our problem, that should take care of all of the items that were required here. Okay, so that was our belt speed, our actual belt speed, center distance, belt size, commercially available shivs, and the belt. Okay, so there you have it. 10 to 10. It really took us until, let me see here. It took us until step 7 to get 2 shivs that were going to work together. And then we had changed it, remember, to the 8V size. We went with an 8V size, and it took us 2 iterations after that. That's called the design process. It's not always going to, start out with what we picked first. We have to kind of go back and forth and check the numbers. And because we didn't have commercially available shivs for the 5V, we had to switch the size of the belt, right? Oker doker. Any questions on that one? That's a good problem. That's why I have it in there. I really like that problem a lot. It's long, but it covers a lot of good stuff. All right. Was that helpful, Emily? And I am going to stop the recording.